Hello! In this video, we are going to be covering function notation. If a relation is a function, it can be written in function notation. Function notation is read f of x, not f multiplied by x. You might be wondering why function notation is needed. For example, we can write this as y equals 5x plus 8, something you might be familiar with. And you might be wondering why we can't just keep it in this format, like why we need function notation. The reason we use this f of x function notation is because it helps us express the relationship between the inputs and the outputs. For this one, f of x equals 5x plus 8, you can clearly see that the input is going to be the x value and the output is the 5x plus 8. This helps us show that when we change our input, we also end up changing our output. Now, let's practice evaluating some functions. Our first function here is f of x equals 7x minus 2. So we're trying to find the value of f of 2. As you can see, our 2 here is in the position of x, which means everywhere we see an x, we want to replace that with 2. This one gives us 7 times 2 minus 2. Which gives us 14 minus 2, which is 12. So we know that f of 2 is equal to 12. Now, we do the same thing for f of negative 1. This means that everywhere we see x, we plug in a negative 1. So solving that, we get 7 multiplied by negative 1 minus 2, which equals negative 7 minus 2, which is negative 9. So we know f of negative 1 equals negative 9. Now, we have this one right here. F of x equals x squared plus 5x plus 6. To get f of 1, we plug in 1 for every single x that we see here. So the x in x squared and the x in 5x. So now we get 1 squared plus 5 times 1 plus 6, which gives us 1 plus 5 plus 6, which gives us 12. What about f of 4? We also plug in 4 for every x we see. This means we get 4 squared plus 5 times 4 plus 6. This gives us 16 plus 20 plus 6, which gives us 36 plus 6, which is 42. So we know that f of 4 equals 42. Now, we can also find values using tables and graphs. So let's look at this expression we have here. Here we have x and we have g of x. And here we have some points. We're trying to find what g of negative 2 is. That means we're looking for the y value when x is negative 2. That value right here is 7. So we know that this is 7. We're also looking for g of 0, which is going to be the value of y when x is 0. So we know that's 1. Lastly, we're solving for g of x that is equal to negative 3. That means we're looking for the x value instead when the y value is negative 3. So when y is negative 3, x is 1. So in this case, x equals 1. What about this graph right here? We're looking for f of negative 1. We're assuming that this graph right here is f of x. So f of negative 1 is the value when it's negative 1. In this case, the value is right here. We know f of negative 1 is negative 1. And for this, we have solve f of x equals negative 2, which means we're looking for the x value when y is negative 2. In this case, negative 2 is right here. So we know that x happens to be 0. Now, let's solve more practice problems where we're given the output and we want to find the input. Our first question is f of x equals 4x plus 5. We want to solve for x if f of x equals 21. What does this mean? It means we know that the end output is 21, and we want to know what value of x gives us 21. So we know the output can be represented in 4x plus 5. We're going to write that down, 4x plus 5. And we know that this eventually is 21. We're going to subtract both sides by 5 to get 4x equals 21 minus 5, which is 16. We divide both sides by 4, and we get that x equals 4. So we know that x being 4 gives us a value of 21 as an output. What about this question? We have f of x equals x divided by 3. We're going to solve for x if f of x equals 2. Same as before, we know our output is 2, and x of 3 is our output, so we're going to solve for x divided by 3 equals 2, and we get that x equals 6. So we know that x being 6 gives us our output of 2. Now we're going to be solving problems where we have expressions as input. So in this case, we have f of x equals 4x plus 3. And we want to find what f of x plus 6 is. So the idea here is that we want to substitute the entire expression every time we see x. So we have 1x here, and we have x plus 6 here. And the idea is every time we see one of this x, we want x plus 6 instead. And the best way is to use parentheses. So we're going to do equals 4. We see an x, so we substitute this entire x plus 6 in there, and plus 3. And now we solve, we get 4x plus 24 plus 3, which is 4x plus 27. So we're substituting this entire x plus 6 every time we see an x. And what about this one? F of 7x. We're doing something similar. Every time we see an x, we're going to put in this entire 7x. So in this case, we have 4 times x, which becomes 7x plus 3. Our answer is 28x plus 3. What about this problem here? We have h of x equals 2x squared plus 4x plus 1. Like last time, every time we see an x, we're going to put in 2x for it. We're going to have 2 times x, which is 2x squared, plus 4 times 2x plus 1. This gives us 2 times 2x squared is 4x squared, plus 4 times 2x, which is 8x, plus 1. Our final answer becomes 8x squared plus 8x plus 1. And for this one, we have h of 1 over x. What does this mean? It might look a little bit more complicated, but same like before, we're going to be plugging 1 over x for every time we see x. Do that now. So 2 multiplied by 1 over x squared, because we're plugging in 1 over x for every time we see x, plus 4 times 1 over x plus 1. This gives us 2 times 1 over squared plus 4 over x plus 1. Our final answer is 2 over x squared plus 4 over x plus 1. Finally, we've gotten to our challenge problem. So, the problem is we have the function f of x equals x squared minus 9. A is to find f of 1, B is to find f of a, C is to solve for x when f of x equals 0, and D is to find f of 2x and 2 times f of x, and to find out whether those are equal. Comment your answers down below. I will also have the answers listed in the description so you can check your work. And that's the end of today's video. Thank you so much for watching.